Okay, hi everyone. I hope you can hear me. I hear myself, so it's got to be good. My name is Alina. Very excited to be here. This is actually my first year at Devoxx France, because until this year I didn't realize speaking in English is an option here. And unfortunately, my French is rather limited. But yeah, finally here, so very excited to be here. And again, thanks for coming. And in this session, we will talk about GraalVM, and more specifically, this ahead-of-time compilation native image part of GraalVM, and we will see how we can make our applications even more awesome with GraalVM. And I hope that by the end of this session, you will be as excited about GraalVM as native image as I am. So a little bit of intro. As I said, my name is Alina, and this is how you can find me on pretty much every social media. If you want to ask any question, have a follow-up comment, or ask for links to demos, etc., that's how you can find me. And I work at Oracle on GraalVM, and more specifically at Oracle Labs, which is an R&D unit at Oracle, where we're doing a lot of research, creating brand new bleeding-edge technologies, doing cool stuff. And GraalVM has been such a research project for over a decade at Oracle Labs, and now it has been a GA product for, I think, almost 5 years now. And I love open source and communities. That's why I like coming to conferences, getting to talk to all of you. And I'm also very happy to have a chance to be working on an open source project. And I love both programming and natural languages. Unfortunately, my French is rather limited, but I'm very open to learning more. If you want to give me like a lesson, I will be open to that. And the last random fact about me, I am both a cat and dog person. I own a cat, but if you prefer dogs, please don't come after me. I love them as well, and I hope that one day I can get a dog as well. And yeah, if you have any questions, that's a picture and the name, and you can find me on any kind of social media. So let's talk about GraalVM and what it is and what it can do for Java applications specifically. So one thing about GraalVM that may be a bit less obvious is that it's also a JDK. So we all know and love native image. That's a ahead-of-time compilation part, but it's also a normal JDK. So just as you're running your applications on OpenJDK, Oracle JDK, whatever is the JDK of your choice, you might just as well use GraalVM because it's like built on top of JDK. We add more stuff to the JDK. And when it comes to Java with GraalVM, unlike the rest of JDKs, you have an option of how you want to run your applications. So you can just do Java and give it your application and run it on GraalVM as a JDK or JVM, as you normally do. Or you can do this cool new stuff called native image and compile the application ahead of time into a native executable. So with GraalVM, you get this choice. It's not always like all in, all the money on native image. You also can do normal JDK stuff. And there is actually one more kind of secret, crazy way to run Java on GraalVM, but for the sake of this presentation, let's just focus on those two ways. And a bit of a history of the project, just because, well, I like this beautiful timeline a lot, but also we've been busy the past like 12 years working on GraalVM. So it started as long as in 2011 when Thomas Würtlinger, my project lead, joined Oracle and started working on this project. And then we did a lot of stuff over the years, but in 2019 we went GA. So if for you GraalVM looks rather new and revolutionary, I can understand the sentiment, but in fact it has been GA for 5 years now, and folks like Alibaba and Microdoc have been happily using GraalVM in production since 2020. So it's new, but not all that new, and luckily we see a lot of adoption in the Java community lately. But let's talk about native image and this ahead-of-time compilation, and why would you want to take your Java application and compile it ahead of time. So the way native image works and what it does for you is it takes your application, looks at it, analyzes, and compiles it ahead of time into a native executable. And the reason you might want to do this because this native executable in the end can run natively on your platform, and it no longer requires a JVM to run, so it's fully functional on its own. And this way you can kind of get the best of both worlds. So you still have developer productivity, access to libraries, etc., coming from the Java community, but also you have performance and resources usage coming from the native world. And the way it's possible to even build a Java application as a native executable is that when you build your application, and this works in a way that you run our native image command and then give it your application in the bytecode form. So it has to be class files or a jar. That's the format it understands. And then what will happen, we will look at your application starting from its main entry point, and we will try to find all the reachable code. So this applies to your actual application code, but also even to the JDK classes you are using and dependencies that you are using. So we will look at the app, and we will try to find over everything that you actually use in your application is using to be doing what it's supposed to be doing for the sake of removing and eliminating everything else, so that in the end you have a fairly small, fairly compact native executable that has all the code it needs, but it doesn't include any other code that you might not need. And we achieve this by analyzing your app at build time and seeing what's inside this app. One more interesting and unusual thing that we are doing with native image, again at the build time, is we are also performing heap snapshotting. So we are looking at your heap, and then we take a snapshot of it, so that you can also start with a pre-populated heap much faster, because you wouldn't need to allocate those objects. Now, the way this is possible, even in the first place to do ahead of time, is we are doing all of this under a closed world assumption. So unlike running on the JVM, everything that there is to know about your application needs to be known at build time ahead of time before it actually ran. And we will get back to that later on in the presentation. Now, if you have heard anything at all about native image, you might have heard that it's great for startup time. And we will see that in a second in a demo. So unlike running on JVM, your application, and it can even be a fairly advanced web server, let's say that you have built with Spring Boot or Micronaut or Quarkus or whatever is the framework of your choice. So instead of seconds or a second, it can start in a matter of milliseconds. So if you have heard one thing about GraalVM, you have probably heard that applications start fast. But sometimes when I talk about this, people tell me, OK, but I have, let's say, an enterprise application. It's long-running. I don't redeploy it that often. I don't build it that often. So why would I care about startup time if, let's say, I start it and then it runs for days or maybe weeks, right? And I agree with you that it's not all applications that care about startup. You might care about it, let's say, for serverless, for microservices in the cloud. But indeed, for longer-run applications, that's not always the most important metric. Luckily, this is not where the benefits of native image end. So because we no longer compile the code at runtime, unlike JVM does, so the reason why some bigger applications on the JVM might take a bit longer to start is because, as we know, there's a lot of work the JVM has to do before it actually can start and warm up and then finally run your application with the best peak performance, because it needs to profile, needs to compile, needs to make sense out of your application. So native image offers you a trade-off where you're doing all of that work at build time, unlike the runtime, because we think that it's the case that more applications are started more often than they are built. So it kind of makes sense to shift all that work left to the build time. So you could do it once, and then you can start it as many times as you need, but you don't need to go through all that warm-up anymore. And that saves time, so hence the fast startup, but also it saves memory and CPU usage, because at runtime, we no longer compile, we no longer load classes, we no longer optimize. It's all compiled and build time. Now, there is one more interesting performance aspect of native image, and that is that the performance of our app will be very predictable over time. So on the JVM, you probably know when you start your application, it takes a bit to warm up, but then when it warms up, it runs with a very good peak performance. And it's a curve that goes more or less like this. So with native image, it's more or less flat, and you get more predictable performance from the very first milliseconds, or as the Spring Boot people put it, you get instant performance. So as soon as you start, you can run your application fairly fast. And also, it has a number of other benefits, such as improved security and compact packaging. We will get to that in a second. And luckily, because of all those benefits, it's quite recognized in the Java community, no matter which framework you're using, or cloud vendor, or library. Most of them at this point have support for GraalVM and native image. But maybe enough talking, and let's look at it in practice. So the very first thing that I want to show you is a Spring Boot app. Let me just expand this. So this is my app that I just generated by going to start@spring.io and adding my dependencies. Cool fact, when you start adding dependencies at start@spring.io, native image is the first thing that you see on the list. That's pretty cool. So I added native image, I added Spring Web, and I think that was it. And I also added one endpoint, so we have something more fun and interesting to look at. So let's see if we can run this app and how exactly. So first, let me check my Java version. OK, and we are on Oracle GraalVM version 22. So that is the latest released, 2 months ago, version of GraalVM. Let's see if we can run it. And as I mentioned, it's a normal JVM. So we can just run our Spring app on it as the JVM. So it runs and it starts, and it took maybe let's round it up, 1.3 seconds to start. And going back, okay, this is not the app that we need. It will be localhost hello. So we get our message. So far, so good. But we can probably do better. And for that, let's look at our POM XML. And this is the structure of my project. So we are using Spring Boot 3.3 milestone 3. We are using Java 22. And we also have this native Maven plugin that Spring will add for me if I want to do native image as a dependency. This plugin is actually from the GraalVM team. That's kind of a unified way to build applications with native image. Luckily, many frameworks integrated, so you have like one unified standard way to build applications with native image. So let's compile it. And yeah, let's remove all this. And let's do Maven p native. And then for Spring Boot, it will be native compile. You can tell that I have a lot of faith in my little mobile phone hotspot, but so far so good. Okay, so it first ran my application on the JVM, so what it's supposed to be doing, package, so far so good. Then we see this long, kind of scary native image build command, but that's because just we have a lot of stuff on the class path. And for me, usually the most helpful section is this one, where native image will start the build. And now we have this very kind of user-friendly, helpful build output, where we show for each stage what exactly is going on. And we have a better understanding of our build, and we can compare our builds across time. So for example, in my case, it says that I'm using GraalVM Java version 22. It has some info about my target machine that I'm building on. It's saying that I'm not using PGO as an optimization. And it's saying that I'm using some experimental options. And as we are stabilizing API, we want to warn users that in the future, like, reconsider those options, because we are stabilizing the API. What is also cool, I mean, there are a lot of steps to be happening in native image build, because to be honest, it's doing a lot of work, right? So we need to analyze the complete application. As you can see, even for this fairly small app, we have discovered this many reachable types, fields, and methods, which is insane. And native image needs to make sense out of all of this and then compile it and package into a native executable. So it's a lot of work, even for a trivial app. And you can see on the right how much time each step of this process has taken, and also the memory usage of each stage. And if you look closer here, you can see that I would say for most of the steps, we are staying below 2 gigs of memory. And I got this question just a couple of days ago. So like, how many resources and more specifically memory do I need if I want to do native image builds? Because it seems like it might be a lot, because a lot of work happening. And indeed, for a larger, like, enterprise-grade application, it might take more resources. But something like this, you can totally build even with 2 gigs. That I wouldn't recommend, but it more or less stays within 2 gigs. And then on things like Git Actions, you can definitely build native image applications without any problem. But with all the talking, we have generated our native image application. So let's see what's in our target directory. And maybe just let me move this higher up. OK, so let's do this, target. And we see our demo that is freshly generated. So there is a time zone difference. So let's run it. Target demo. And it runs. And this time it started in 47 milliseconds. And if we go back and close this and open this again, we get the exact same message. So this is startup, but this is how you build such Spring applications. And we're not going to measure the memory now, but I also want to mention that the memory requirements of this app will be much smaller than running on the JVM, because again, we are not compiling our application live. And talking about memory, I like to go back to the session that Josh Long and James Ward did a couple of years ago, when they also built such an app. And it was still like early days of Spring Native. And they measured the memory, and they said, OK, our RSS usage here is around 100 megs. How often it is that you give your Java application 1 gig of memory? Like, raise your hands. Many people raise their hands. And they said, well, now you can deploy 10 such applications for that memory footprint of your Java app, or maybe reduce your memory usage by 10x. So I think that was a very nice way to put it. OK, let's go back and let's see what else we can do with GraalVM. OK, so let's say for my application that I have just built, I want to add more libraries, and that's again a question that I get a lot. So let's say I want to build a project that will use libraries X, Y, Z, or maybe I have my existing project and I want to migrate it to GraalVM. So how do I know which libraries will work out of the box? And for that, we have this very nice page called Ready for GraalVM Native Image on our website. So if you go here, you can just Google saying Ready for Native Image. There is a very long list that you will get tired of scrolling through of libraries that are known to be working with GraalVM. Now, if something is not on this list, it doesn't mean that it doesn't work. It probably means that it hasn't been reported yet, because this is a community-maintained kind of list of libraries that test and integrate and constantly run with GraalVM. But as a quick way to evaluate whether your project will work well with GraalVM in terms of dependencies, this page is very helpful. And if your library is not here, it might still work. It just hasn't been reported to us yet. But to evaluate libraries quickly, this is a very helpful place for that. Now, let's say we want to add libraries indeed, and why could that be maybe challenging with projects that are working with GraalVM? So when we talked about native image and how it builds applications, we mentioned that this happens ahead of time. And this means that everything there is to know about your application needs to be known ahead of time. So some more dynamic Java features, such as reflection, they work with GraalVM, but they might require a bit extra effort to work. So talking about libraries, this is going from like the best user experience to like a bit more effort to make things happen. This is how libraries might work with GraalVM in terms of reflection, resources, those more dynamic Java features that are a bit more challenging to the closed world assumption. So on the example of reflection, how reflection works with GraalVM, because maybe some of you have heard that GraalVM doesn't support reflection. Have you heard that? Okay, that's a lot of people raising their hands. That still makes me very sad and depressed. GraalVM does work with reflection, but there are things to know. So the things to know are the following. Reflection is very dynamic, as you know. So it's kind of hard to tell native image ahead of time what exactly will be happening reflectively at runtime, because runtime hasn't happened yet. But there are things we can do about it. So more kind of predictable reflection calls, native image will figure out of the box. So if you're doing something fairly reasonable or that native image can predict, there is no help needed from your side. Things will just work as you're compiling your application. Now, if you're doing something a bit more advanced or custom or non-trivial, native image might need help from you to make those things happen. And that help can come in the form of configuration files, JSON files, or your framework, library, etc., can ship those config files for you. So it's not necessarily that you would need to provide those files yourself manually. And this is, again, going from like the best possible scenario to a bit more challenging scenario. These are the things how libraries can work with GraalVM. So a library can work with GraalVM just out of the box because it's written in a way that maybe does not use reflection or use reflection in a way that is understandable for native image. And lately, we see a lot of those libraries coming up saying, hey, we love GraalVM. We are GraalVM friendly from day one, from scratch. So that is great. Now, the next possible scenario for you as a user is that the library is doing something that is more challenging for GraalVM, so reflection, accessing some resources at runtime, etc. So in that case, it's very cool when a library can include a config for native image. So as a user, you don't even notice, things just work for you. But the way this works from the library side is that they can ship config, and it looks like a JSON file. And here we are looking at H2. So in the past, I used to show a demo when I would build an app with H2, and it wouldn't work because it cannot understand the config, but I would produce that config automatically. Now I don't even have to because H2 themselves include config as you are pulling your dependency. So this is very useful. And again, I'm maybe going a bit too deep into this, but I just want to show you how things just might work for you as you're building your apps. So this is another positive scenario where a library just works with native image. And for those dynamic features, it tells native image what exactly needs to be available and have. And this is not even, I mean, this file is rather long, but for many projects, it's shorter. So it's not that complicated in the end. So library might work with GraalVM out of the box. It might ship config, but also we understand that not all libraries yet can or are able to provide config for GraalVM. And for that, we have created this centralized repository on GitHub. because we thought that maybe users can, or maintainers, or even ourselves, we can figure out config for many popular libraries. We can store them centrally on GitHub. And then our tooling, so our Maven and Gradle plugin, can go and pull this config automatically. And again, libraries just work for you because there is the centralized place for the config. So the next, I would say, positive and good scenario is if your libraries have config in this centralized repo, and if you are using our native build tools, so Maven and Gradle plugin, they will go and they will discover automatically this is now on by default config from this repo, and they will pull the config from there. So there are also a lot of libraries in here. If you take a look, many popular libraries and frameworks have config here. So again, all of those things will just work for you with GraalVM and native image. Now, if you're using a framework that supports GraalVM, such as Spring Boot, Macronaut, Halidon, Quarkus, and if you have maybe your own custom code that you wrote yourself and you want to do reflection, etc., again, might work out of the box. But if not, most of those frameworks have APIs or annotations that help you tell native image, OK, I'm planning to access this element reflectively. Please register this with native image so that this again just works, because native image now knows that it needs to make this class method of field visible and pick it up as it's building your application. And then again, final step, or like almost final step, we also have this tracing agent in native image that helps you run your application on the JVM. And then it will look at what your application does, and it will produce this config automatically for you, because it seems like it should be possible to run your app on the JVM and just automatically produce config. And it's indeed possible. You can run on the JVM with the agent, and you will have as an output those JSON files that you can just pick up to native image. And things, again, will work in case your library is something maybe custom that you develop yourself, and there is no known support for GraalVM. And then the last step, you can also write this JSON file yourself. But this is the very last step. I'm kind of hoping, I mean, this kind of looks scary, but I'm hoping that you will never go past maybe those two, three steps where things are either included on the library or just work out of the box, or you can pull from GitHub. So I hope that you will stay within those first three bullets. Now, if you want to keep building our application, we might have a need for testing. So where do we stand with that? There is support for GraalVM from JUnit, and also all the frameworks that I have mentioned also offer some kind of support for testing applications in the native image mode. And even for integration testing, if you want to test your integration, let's say against database or something, frameworks such as Macronaut has, for example, this module called Macronaut test resources, and then Quarkus, maybe you have heard, has Quarkus dev services, and all of that works in native mode, kind of leveraging test containers. So if you want to do integration testing, that works with native image as well. But as a rule of thumb, we always recommend that you keep developing your application on the JVM, testing on the JVM, and then you compile to native as a more or less last step in your deployment process, or in your CI/CD, or maybe if you're introducing a new dependency. But in general, you don't need to recompile your code every 5 minutes, especially if you're introducing changes mostly around business logic. Things just work, and then you will just double check once in a while or in CI/CD build to native to make sure things work. But in general, our recommendation is that you build the application on the JVM and stay in the JVM world, and then compile to native image less frequently. OK. Let's talk about performance, because I work on a compiler, so obviously this is something we are all very passionate about. So what do you think, like taking the same Java application, running it on JIT, so on the JVM, versus running it AOT, which will be faster in terms of peak throughput? So will AOT be faster than JIT? OK, like barely 5 hands. You people are very skeptical. OK, I assume those who haven't raised their hands assume that JIT will always be faster than native image, than the AOT. And I understand where this is coming from. Indeed, JVM is amazing at peak throughput. It can profile your code. It can adapt during the runtime. And in general, it's an amazing piece of engineering, and it's very hard to build it at its own game. But in addition to those benefits that native image already has, so startup time, resources usage, etc., we also want to give you great peak performance. And we have this ambitious goal that we want to give you the same peak throughput that you have on the JVM. And we have done a lot of work towards this in the past 2 years, and now we are feeling confident that more and more apps should be looking like this. This is Sprint Pet Clinic, and this is in our measurements running on C2, which is the default JIT compiler in the JVM OpenJDK, and then running on native image with all the optimizations that you can also apply yourself. And here we can see that native image is on par and even slightly better than the JVM. And it's our goal, again, ambitious, but we are working on it, that all the applications should have performance profile like this, where even ahead of time compiled code can be faster than JIT. And I understand it's very hard to believe in this, especially coming from the JVM world, because we all know and love JVM, myself included. But there are areas in which AOT has benefits comparing to JIT. For example, we have our closed world assumption, and this means that we can apply more aggressive optimizations because we know exactly what will happen at runtime, and there will be no surprises for us at runtime. So we can apply more aggressive optimizations. B, we can also dedicate time and resources to optimize your application more during the build time, because we are not competing with your app for the resources as you run your application. So this can be seen as a maybe very unusual perspective, but there are areas in which AOT even has an advantage comparing to JIT, and we are working on making sure more and more apps look like this. Now, this is peak throughput, but we also care about resources usage, and I love this beautiful chart. It takes a couple of seconds to parse, like I'm not gonna lie, but let's look at what's happening here. So here we are measuring operations per gigabyte per second, so how much throughput you can get per given amount of memory and per given amount of time. And some people call this throughput density. So that's basically how much valuable work you can get out of your resources, out of your machine in the given amount of time. And we are mapping that against XMX settings to see if you give your application more or less memory, how does that affect the memory efficiency of your app? So how does that change how much throughput you get per those resources? And we have two observations here. So the blue line, that is again C2/OpenJDK, and the orange line, that is native image. So two observations here are that per given amount of resources, native image will give you always more throughput per memory because it uses less memory at runtime, as we already discussed, but peak throughput is comparable. So it's an easy kind of ratio where if you do the same work, but you use less memory, you will be more efficient. And one more observation here, so somewhere around, I would say, 512 megs there, you can see this kind of sweet spot, where native image is almost twice as efficient as C2. And the conclusion here is that seems like for specifically applications with maybe, I would say, small to medium heaps, so 512 megabytes, maybe to 1 gig, you will get as much as 2x throughput per memory as you would with C2. So probably if you're deploying applications to the cloud, this can be a very relevant metric for you to look at. And I will not stop here, but even if you want to do things like have very strict SLAs for latency requirements, you can also get good latency with native image. It's possible even for latency. Okay, and let's talk about some tips and tricks and recommendations that I can give to you for building applications with GraalVM and native image. So let's say you want to package your application because you're deploying containers and you want to minimize that container image size. What you can do there? And you have obviously a lot of options. And the blue ones here, this is still running on GraalVM as a JVM. And then the orange one, that is the native image world. So if you want to minimize your container size because you want smaller, more compact containers, maybe you want to deploy and scale more easily, you can build static native images, so fully statically linked, and then you can use distroless images, and this way you can take your container image size quite a bit down. And for building applications, so I mentioned when we were talking about the build process that native image produces native executable versions of your app, and they are platform specific. So this means that if I'm building on my MacBook, I will produce a native executable for MacBook, and then we cannot do cross-platform compilation, unfortunately, because we need some JDK classes that are specific to each platform. But there is a fairly easy solution to that, and that is CI/CD systems. And I'm, for example, a big fan of Git Actions. And we have our own Git action. So what you can do there, you can set up your repo, you can set up Git Actions, and there you can produce native executables for whatever platform that you need. And maybe I can even super quickly show this on the example of my native Spring Boot that I have set up here. And if I go to my Git Actions, That is the last change that I have made, and as a result of that, I have completed jobs, and I only have set up macOS and Ubuntu because I don't need anything else. But then I can take this binary and give it to someone else, or even run on my own machine and just use GitHub Actions as a, let's say, building platform for my app. So this is something that I would recommend. And again, check out our own GitHub Action. It will also help you a lot. Okay, and I want to say a few words about security because this is, I would say, undervalued, underestimated angle of native image, but it's very interesting. So we said in the beginning that native image eliminates the code that you are not using. And this way, it's also reducing attack surface because there is less code in the end. We're removing everything you don't need, so there is less for possible people to attack your application. Now, things like reflection, serialization, etc., as we mentioned, that require a specific allowed list that can be coming from you or coming from a library, framework, etc. And this can be seen as a limitation, but in a way, it also gives you a bit more control and awareness over what is happening in your application, because without your explicit OK, or like OK from your library, framework, etc., those things are not possible. And this way, those attacks that you might not suspect also will not happen, because unless you allow those lists for specific classes, types, etc., those will just not be available to attack in native image. We also have support for SBOM, so you can see what's inside your native executable. And then again, there are some attack vectors that target the JIT compiler specifically. So those are not possible just because there is no longer a JIT compiler at runtime. It's all ahead of time compiled. Okay, and I want to give you a few recommendations. Maybe you want to build a new app, or maybe you want to migrate an existing app to GraalVM. So where would you start, and what would I suggest that you do? First thing I would suggest to check what is the framework that you are using, and if maybe you can move to a slightly newer, but not the newer versions that already works with GraalVM, that will help a lot. So Spring Boot, Micronaut, Quarkus, Halidon, they all work with GraalVM. And if you can move to the version that works with GraalVM, then you are good. But let's say you're not using any of those frameworks, or maybe you are like on an older version of the framework that is not working with GraalVM yet, then I would add our native build tools. Let's see if I can just open, yeah. So this is our native build tools, and that is Maven and Gradle plugins from GraalVM team. So I would add those, and then those will help you compile, test your application, use dependencies, etc. So if you cannot move to such a framework, I would say moving to those will be very helpful. And then you can evaluate your libraries by going to the page ready for native image that I have showed before. Now, for building and deploying and testing your application, I would suggest that you still build and test your application on the JVM, and then you test in native, either when you add a new dependency, or if you are touching things that might be sensitive towards native image, so reflection, serialization, proxies. Then you would test the native image, but you don't need to compile to native image all the time. It's just like not needed because things will work. And small tip, but I like this one, there is this quick build mode in native image that you can enable by passing the -ob flag. And this will speed up your builds a bit. So if you are still building your app and you just want to make sure that things work, this flag will give you slightly faster, maybe like 20% faster build. But I find it very helpful when I need to constantly rebuild my app because I'm doing a demo or I just want to show something. And then for cross-platform builds, use something like CI/CD systems. Now, there is a bunch of additional optimizations that you can use in native image to get that amazing peak performance that I was talking about previously. So the most powerful optimization that you can do with native image is called PGO, and that is Profile Guided Optimizations. So the way this works is you first, as a first step, you will build an instrumented version of your executable, and then you run it and you apply relevant workloads to it. So the idea there is to, I mean, you will still get to do this even if you cannot apply relevant workloads, but you can, if you can more or less replicate real-world workload, this will give the best result. So you run your instrumented app, you apply workloads, and the instrumented app will collect and store profiles for your app, kind of like the JVM does at runtime. So at runtime, JVM looks at your app, collects profiles, and then makes decisions based on those profiles, which methods are hot, which loops are hot, etc. And we can do the same with native image, where you collect those profiles and give them back to us when you build a native image. And then at the second step, you will build a native image that is aware of the actual runtime behavior of your app. So it kind of has an insight into what's happening at runtime. And this way you get to combine the best of both worlds. You have the runtime information, and you also have the power of ahead of time compilation. So that's the best one. And if you can do this, I would recommend checking this out. Now, in situations where you cannot do PGO, or maybe you don't care about performance that much to do this two-step process, it seems like predicting profiles for the app can be a good task for ML, for an ML model. And indeed it is. So native image comes with a little ML model inside. And if you cannot do profiles yourself, this optimization is on by default. And what it will do, it will try to look at your app and predict possible profiles. And then we will perform optimizations based on those predictions. This will not be as fast as this custom tailored one that you would do yourself, but it will give you about 6-8% performance improvement over not having this in the first place. Now, for GC, there could be different optimization strategies, but as a rule of thumb, we always recommend checking out G1 GC in our observations that gives the best peak throughput for native image. And then the last fairly small one, if I know that I will run my app on this exact machine, I can pass this MARC native flag, and it will make use of the specific hardware features of my machine, and it will build an app that is optimized towards this machine. If you are building an app for distributing, you can do a MARC compatibility, and that it will run more smoothly on every possible MacBook out there. But if you want to tailor your app towards a specific machine you're building on, a MARC native will be very helpful. OK, so what's next for GraalVM? Recently, we have released GraalVM for JDK 22. So the way our release calendar works now is every time there is a new Java release, there is also a new GraalVM release on the exact same day. And the idea that we have is, we want to align closer with the OpenJDK community, but also we want on the same day that you have new Java features, we want to give you new GraalVM features so that you can use both of them in one place. And you can read more about that on our blog on Medium, but actually I want to show you two demos built with the latest GraalVM version. OK, let's see, and let's start with this one. OK, have any of you already tried LangChain4j? OK, some people. Actually, there is Lizzie running somewhere around here. She's from the LangChain4j team. You can ask her more questions. But I want to show you this demo that I have here with me. And what this app does is we are taking user input, and then we are talking to the OpenAI API to produce answer to that user input. That can be a query, a question, a comment, whatever. And I can run this on the JVM. I have my little script somewhere so I can save myself the typing. So let's run this app, and let's see if we can make sense out of this model. Let's do the JVM first, and let's ask, I don't know, hello, how are you doing? OK, as an AI, it doesn't have feelings, predictably, but it does work. One thing that I want to mention here is response might take longer because we are going and talking to the API. So I would not treat this as a performance metric or something. Let's see if we can ask it something else. Let's do what is Java? OK, this is taking too long for my patience, but we got the answer. OK, Java is a high-level class-based, object-oriented programming language, blah, blah, blah. OK, seems JVM. OK, seems accurate enough. But I think we can take this app one step further. And for that, let's see what we have here. Target. And I have this natively compiled version of my app. It's fully working on its own. The size is 47 megabytes, so I would say that's quite good. Let's run this, and let's see if it can do the same thing. Let's maybe do what is GraalVM. So let's compare the nodes. GraalVM is a high-performance runtime that provides significant improvements in application performance and efficiency. OK, it also talks about all the other languages. I did not mention this in this session, but I would say overall it's good enough. OK, and let's do just one final query to make sure this is not baked into the image. It is indeed talking to the API. let me see if I got this. So who is, okay, God help me, Thomas Yurenko. No typos, should be fine. Okay, let's see what we got. Come on. Okay, Thomas is a software developer and a researcher who has made significant contributions to programming languages, blah, blah, blah. Got PhD from JKU. Okay, fair enough. So Thomas is our project lead, so you can see that it does work, it does talk to the OpenAI API. You can totally build such application as native. In fact, the way I built this app, it did work for me out of the box, so it compiled to native without any problems. It was showing me some annoying warning from some dependency that line change for J is pulling in. So I did use like one small config, but overall this app has just built. And I want to show you one more app, again, built using GraalVM, the latest GraalVM for JDK 22 release, and that is this one, Modern Java. And you probably know my colleague, Nikolai Parlog, and he has this great demo, Modern Java. Where is it? This one. So this is a demo that he has built. It's a little GitHub crawler that you can run, and you can give it a GitHub link, and it will go there, crawl the page, understand what are the links on that page, and present those links to you. And the purpose of this demo is to showcase all the latest features that are available in Java 22. So records, wheel show threads, web server, all the cool stuff. So I decided, why not take this demo one step further? I forked it, and I have it here as native modern Java in action. So this one. Oh, what did I do wrong? Native modern, this. Yes. So this is my fork, and if I compare it back against Nikolai's app, this is what I did. I extended the README just to add instructions how to build, and all I changed in the actual app, I added native Maven plugin. That's why I'm always saying, please add our plugins. And I enabled preview because we are using preview features, and I just specified the name that I want to have for my application. So let's see if we can run this as well. Okay, so far so good. And we have it compiled, I believe, in Target as well. Yes, native modern Java. Let's just hope I haven't abused the GitHub API today, but we will see. So let's give it a try. Target native modern Java, and we need to give the URL that we want to crawl. So I want to give this one epic where we are talking about one of the upcoming projects in GraalVM, layered native images. So let's do this. Okay, I'm giving my URL, and I'm specifying the desired crawl depths. Okay, going good. And it already shows me the output, so it found that many links on the page, and those are the links. But it also created a nice little server for me at localhost 8080, only without hello. And if I go there, I see the result of the crawl, all the links that have been found on the page, and the classification of what is each link. And this has beautiful design courtesy of Nikolai, but it's now running as a native app. So I think this is pretty cool. And let's go back to the slides. So this is what you can build with the latest Java 22 and GraalVM combined. Yes, I'm running out of time, but I do want to mention two ambitious projects that we are working on. So what is coming up next for GraalVM, and what are the big things that we are working on? One is called layered native images. And we want to introduce a brand new, totally new way to build native images. So if you have ever built a bigger application with native image, you might have noticed that build times can take a while, because as we saw, it has to do a lot. So I see people nodding, but it has to do a lot. So it needs to analyze like thousands of classes, even for a federal travel app. So what we want to do is we want to give you an opportunity to compile a few base images. Let's say I want to build a Spring app, so I will have my Spring base already compiled. I will have my JDK base already compiled. And then every time I'm introducing changes, I'm only recompiling my user code, so the code that I actually wrote. And then those bases are already compiled, and it only depends on those bases, but I'm only recompiling the actual code that I wrote. So with this, we are planning to take down compilation times to a matter of seconds or a second that you have on the JVM, because you are not recompiling all other code anytime, only your own user code. So that will be one benefit. It's better developer experience because you will have faster builds and probably even less resources usage during the build. But also even for deployment, this can be interesting because let's say I want to have 5 instances of my Spring app. And again, I can deploy it in a way where I have my JDK base, I have my Spring base, and those 5 instances depend on the same base and share the same base, let's say in the cloud. So we can also have lower resources usage in the cloud because those instances depend on the same base images and kind of share them between each other. So this will be pretty cool. This will take a while to make it happen because it's a brand new concept for us, but we are actively working towards it. And one more thing that we are working on is called GraalOS, a very ambitious name, but I like it. So we are working on developing a platform where you can deploy your application not as a container, but a native image. So you don't need to deal with containers, and even that little container overhead, it's already gone because you are compiling your application and deploying just as a native image. OK, and I see that I only have 10 seconds left. So for that, I want to share those 2 QR codes. You can, again, talk to me on Twitter if you want to ask any question or follow-up. And here is a QR code for links, demos, blog posts, videos about GraalVM. So if you want to find them, those are the 2 good places. With that, thank you so much for coming to the session. You can still ask me questions, and I have some GraalVM stickers. And please rate the session in the app. Thank you so much.